Good morning. I'm Doug Gelbach, as was mentioned. I'm happy to be here. I'm representing Mr. Wade Shen. He recently took over the XDATA program from Dr. Chris White, and some of you may be familiar with Chris. Chris is leaving actually next week. He's departing, and I'll talk a little bit about the procedures at DARPA, but DARPA brings in program managers that have a limited time frame. Basically, we want to move them in and out and get fresh information and fresh ideas into the system. And so from 1958, when DARPA was first started, that's how the process occurred. They'd bring smart guys in, do great stuff, give them a lot of autonomy and a budget, and tell them to do great things. And currently, that's basically how DARPA executes its operations, is through programs and program managers, and they currently are doing about $3.6 billion of research and development through these very high, small offices and these dedicated programs. And so what I'll talk about today is how we envision tech transfer, some of the different aspects of the software that we've developed, and it was a nice lead-in. The previous presenter had a couple of our capabilities. Probably didn't recognize it, but we'll point those out. We'll talk about further transition information and then how we support open source as a community. So normally when DARPA develops a thing, they go out to the technology community through a broad area announcement. They solicit input. They bring that input back, go through it, select certain performers to do work, and put them under contract, and off they go to build something. And at some point in time, somebody delivers a thing, and that thing could be, GPS or stealth technology, the internet, the M16, any number of things. They could hand that over, and typically that process then moves to one of the services who take it on as a program of record and move it forward as a thing. We're a software program, and so the difference between software and physical things and systems is that software is fragile. It's time limited, and often it's old before it gets in and goes through the procurement process. And so the challenge that we face is transition, and we want to be successful by doing transitions and working with people, understanding their needs, and then moving software to them that's useful in their domain or their area of interest. And so once you get through the normal process, you end up here. And somewhere in this chart is the next point where you go through the acquisition cycle and that whole thing, and a very complicated process, and so it can take a while. And so what we did, and what Dr. White instituted originally, was the requirement within the BAA that all of the performers develop software, and that software be liberally licensed open source software. And so by taking that stand initially, we've eliminated a lot of the challenges that are faced normally down the line by other programs. And so even a piece of software that's developed by the government, after the life of the program, once the program ends, it normally takes 4 people. It takes 2 contracts and then 2 agents in the middle to transfer software between someplace that developed a GOTS product to someplace that somebody wants to use a GOTS product. And so by going down the open source route, we eliminated that challenge and those difficulties, and then we're hoping that going forward, that will enable transition and integration of these products down the line. And so we've, recognizing that software is fragile and time limited, we've approached the transition early on. So instead of being at the end of the program, which is a 4-year program, and coming out and handing over a number of disk drives to somebody and saying, here you go, here's XDATA. We work very closely with a lot of partners And we spend a lot of time going through these processes and interactions so that we have, connectivity through to the end user. And one of the methods that we have done and been successful with is basically hand-holding, where we've applied program resources with an organization who had an interest in a specific need, and we've applied resources and embedded people in their facility or on their systems, integrated the software onto a testbed environment, and then migrated and aided them in migrating systems and software to mission systems. We've also had some success with getting our performers under contract elsewhere. And so somewhat similar to what you saw previously, where Kitware and Pat Hanrahan were identified. Those are our performers, and we funded that work, a lot of that work that resulted from those guys you see in these different areas. So that's another advantage of open source software in the development, is that it enables people who are participants in the program to take their developed work to market as soon as they're able and interested. Some of these groups, for example, the Stanford guys, are somewhat interested, but not necessarily as interested as some of the commercial guys like Kitware to get things to market, get their products out there. Another way that we have found been somewhat successful is we have all of this software on the DARPA.mil homepage, and I'll show you the link a little later on, but it's called the Open Catalog. And so the catalog started with our program. It now contains 18 different DARPA programs, and it's acting as a repository for work. And so DARPA has a history of doing a number of great things, but had a hard time looking back to the past and really grabbing a hold of all of the performers and the products and all of the things that were produced as part of the program that the government paid for, especially if it didn't result in a transition to a service agent. So what the Open Catalog does is provide a repository and a pointer for this work, and allows it to live on and acts as a transition model. So I'll show that shortly. And one of the other aspects of the program is that we don't build systems. We build components, and I'll talk about this in more detail, but when you build, from our perspective, when we build systems, we become the system program. And once you become the thing, it becomes hard to step out of that. And so we have tended to stay away and develop expertise within components. And so that's how we've kind of approached. And also it recognizes that each of the users that we interact with has an infrastructure and has an enterprise that they're not going to throw out, right? Nobody is going to say, I'm getting rid of all my infrastructure and I'm going to take on this XDATA thing because, we have interesting software. So that recognition has also enabled us to move components in different parts of what's been developed into different places and systems. So I'll talk a little bit about the stack and the performers, and generally, I'll just kind of brush over most of it unless there are specific questions as we go. But what I really want to convey is that the XDATA program, which is available, and you can go onto the Open Catalog to see what has been developed. There's the software, and there's a tab for publications. There's 120 academic papers that have been published. We post data, and it's all searchable. But really, what we have a hard time conveying to a lot of the people that we interact with and a lot of customers that see our program is the scale at which the work is occurring. So we have 26 developers under contract. We're about a $100 million program over 4 years. And so we have many things going on. We have many performers that are doing things. And we tend to look at it as a workflow from what the data process that you would want to bring in to the platform that you're using all the way through visualizations, and ultimately with the goal of answering somebody's question. So we want to We want to ground our work in close interactions with users. We want to make sure that we're informed about what the needs are, but then also make sure that we're advancing data science and moving things forward. And we're also very meritocratic. So you'll see performers on here that are no longer with the team that we've cut and changed out and brought in, but it's a good snapshot to just keep them up there as we move forward. But you can see there's a lot of work being done, a lot of different levels of platform and infrastructure and all the way through visualization. And so we'll start with Mesos, and it's a scheduling, Dockerized, containerized scheduling capability that was developed at the AMP lab. And we have an infrastructure that we have built, and it contains now mostly high memory processing, cloud distributed architecture with a couple GPUs. And the GPUs are known as the loneliest cluster because they don't get a lot of work, but we do have a couple efforts underway to develop some GPU enabling technologies, and we'll talk about those in a minute. Spark is another thing that was developed under the AMP lab as well as the XDATA program. It's an Apache top-level program, and I'm sure you're familiar with. As was mentioned before, Anaconda, Numba, these enabling Python packages developed by Continuum, one of the performers on our program, pretty simple to use, allows you to extend these packages into these different computing environments and then package everything up and increase your benchmark speed. On our infrastructure, we tend to benchmark everything so that when we do come to a program manager or a government person who's often probably talking to a lot of you in this room, that they have some sort of mathematically based comparison to make. And so we offer that to them as well through baselining through our work with NIST as part of the team to understand the capabilities of these different software components on this set infrastructure, allows them to go and then make a comparison, and also enables NIST to have a more robust understanding of what metrics within big data and these distributed frameworks mean. Julia is another team on our portfolio, developing a computer language, very high level, simple syntax, allows you to do a lot of interesting things, parallel process very quickly, and then a significant speed increase. It's getting a lot of interest from the econometrics folks as a language that's easy to use and also very powerful in the regards. As mentioned before, there was a compiler for domain-specific language. This is the package to Stanford. Allows you to do all this heterogeneous software. The Delight architecture, infrastructure, and then you see list up here is one of the packages that it includes, as well as others. But excuse me. And so that's so pretty simple and also a significant increase. Yeah, I don't know, somebody's. We'll start moving into visualizations. As you saw before, kitware, they do a number of different things, D3 based. Tangelo is one of those things. Most of that is presented in a browser. They also have a web-enabled service called Tangelo Hub that's very interesting, allows you to do a lot of visualizations very quickly. So it's been a big benefit for us to be able to have these processes in place and then allow people to see them. Oculus just recently changed their name to Uncharted after they lost the fight with Oculus Rift. It's a Canadian company. They do a lot of visualizations and very large-scale data. And and they do some interesting plots and graphics and renderings of, data at scale. So, well, how do we do development? We, as I mentioned, want to be partnered very closely with users and understand their needs. But we have a number of folks, a number of teams that have a wide range of participants, and so we do everything at the unclassed level, very, very out in the open. But we conceive and we present to them, to the developers, challenge questions and data sets that kind of drive in certain directions that enable software to be developed that we can then later point to problems that we know reside within different communities, whether they're law enforcement or intel agencies. And so what you see here is a representative snapshot of some of those data sets and some of the different characteristics. We were, from the days in Afghanistan, very interested in threat finance, so we picked a couple lending and micro-lending sites, and as well as Bitcoin. We've looked at cyber, some ISR, social media, and beginning last year started to work on some untextured or unstructured textual data. And so we also, from the BAA point of view, we required the teams to be participants in a summer camp. And so every year they're required to be or have members of their team at our facility in Arlington, Virginia for 8 weeks during the summer. And that's how we bring them together. We force them to work on these challenge problems, and also we cause them to collaborate. Often the different challenges and types of events and interactions that a program will set up cause teams to go and they run in parallel lines, and they go and they produce something, and then there's a competition between them. We have taken a more integrative approach where we've told them that they need to all participate on challenge questions. They need to all develop software that touches each of the problems, and so that forced collaboration, so that a person who's in the ETL side of the workflow is interested in data of a certain type, and a person who's on the visualization side of the workflow is interested in data of a certain type, and they need to work together so that these things work. And then ultimately, we want to have the ability to compare and to provide links to the components and to be able to basically snap them together as we encounter a new challenge or a new problem that somebody wants us to address. We can bring these components to bear in a relatively quick fashion. And so one example is this look at some of the traceroute data, 7 billion trace routes. We developed some processes, Louvain modularity for clustering. We parallelized it, allowed it to run very quickly and be able to process this data as an entire unit. But it allows then the ability to zoom in and out. And what you see here is a representation of those clusters and groups. And when you lay it out on a map, you can basically compare it and see where trace routes occur in the world and the internet. This is another example from Uncharted, formerly Oculus, way to represent. These are 1 billion tweets on the heat map, and then they've developed a mechanism to generate tiles, and so you can zoom in and out. The tiles are pre-processed, and they also have the ability to embed these analytics within the tiles, so you can toggle between different analytics, and you can flip through things that are meaningful to you. It's all very configurable, and so we've worked with using this in social media to understand different aspects over the ground. And finally, this is a snapshot, and this is the location of the open catalog where you can go and see everything that we've done. When you hit our page, you'll see the Performa that's developed it, the tool that they've developed, a short description, and then a pointer out to the GitHub repository where it's located. And you can go to that GitHub page, and you'll see their documentation and the information and a snapshot of what they've done, and some have included demos and different things. We spent a good bit of time last summer working on and making sure that they all had documentation out there that was available and usable. So you should be able to find that and at least be able to explore and play with it. We're always adding new content, and so either our program or one of the others, if you go to that front page, you'll see little banners with new or added information, and that's how you can tell. But you can also tell from a column that's not listed here, which we capture statistics of interactions that the software has had reported from the GitHub site. So you can go and basically see who's contributed, who's looked at it, and that kind of stuff. And so in order to take all of this as a package forward into after the lifespan of our program, once we quit or complete the work, we've established an open source, a DARPA open source office, and it's being run by JPL. And so number of the guys on that team, one of them is a board member of the Apache Foundation, but there are a number of participants in that group who contribute regularly to open source forums. And so they're leading the effort to understand how we, as an organization, enable communities to develop around different types of software, how we move it forward, and how we enable that software to live past the lifespan of the program. And that's really the goal. These individual transition efforts that we have achieved with different organizations are one thing, and we like to see that immediate gratification, and it proves out that what we're doing is somewhat useful. But this is really the end state. The end state is that as an open source community, it moves on and resides elsewhere and lives past the end date of the program. So that's the end of my presentation. Those are our points of contact, and if I can answer any questions that you might have, we'll do that.